Hello everyone. This video is titled Section 2.7 Part 1, Solving Absolute Value Equations. In this video, I am going to be taking you through the Knewton Alta assignment for Section 2.7 Part 1. Now, I must also tell you that the questions that I see in this video aren't going to be exactly the same questions you see when you work on the Section 2.7 Part 1 assignment yourself. But there is the same objective and the same kinds of questions, right? So the way I work on these questions will be the same way you should work on the questions that you see. All right, so just keep in mind, they won't all be the same questions, but the way you work on them and how you would go about doing them are the same. Okay. So here it is. Now you're not going to see the word preview. You'll just see the title of the section, the mastery bar, the objectives, questions here. You won't see the instructor cheat button, right? But you will see the more instruction button, and I've brought this up before. You can click on that to help you out with questions you're struggling with if you ever need. And they'll provide you with more instruction or videos or something to help you out. Alright, so the first question, and this is the only objective in this section, right? Solve an absolute value equation. So every single question is on this objective. And I'm going to write this on a separate piece of paper and work on it. Alright. So when solving absolute value equations, the first step is to get the equation in the following form. The absolute value of some expression, which I'll call u, get the absolute value expression all alone on its own side. Nothing multiplied by it on the outside, nothing added to it, subtracted from it. So get the absolute value alone and have it be equal to some expression on the other side, which I'll call a. And then you write it in its equivalent form, saying that the absolute value of u is equal to a. This is equivalent to saying the following, that either u is a, right, because remember, absolute value is the distance from 0 on the number line. So if the absolute value of some number is a, then either this expression u is a itself, or this expression u inside the absolute value symbols is the opposite of a, or -1 times a. Right, then the third step is to solve these equations, right? So you're going to take an absolute value equation, write it as two separate equations without absolute values. You solve these resulting equations. And then, of course, check your solutions. Right, check your solutions, and you always check solutions back in the original expression, right? Back in the original equation. Alright, so I'm going to be following these steps every single time. Alright. So this equation, this first one I'm given, is already set up the way I want. I've got the absolute value alone on one side equals and then some expression on the other. So the 10n plus 6, that expression is like the u. And the 8n plus 10 on the other side, that's like the a that I wrote over here. So after getting the absolute value alone, which is already is, I'm going to write an equivalent, the two equivalent, what this is equivalent to, this OR statement here with two equations that have no absolute values. Right, this is equivalent to saying the following. Either 10n plus 6, right? Either 10n plus 6 is exactly the same as 8n plus 10, or this 10n plus 6 is the opposite, right? The negative a, the opposite of the quantity 8n plus 10. Sorry about the clutter there. But notice I put minus 1, it's negative 1 times the entire thing. So I will be distributing a negative 1 over here. All right, and then you solve each of these equations separately. Well, the first equation is simple enough. I would subtract 8n. That would give me 2n on the left. And I would subtract 6 to give me positive 4 on the right. And then divide by 2 to get n equals positive 2, right? Or, now this equation, remember I had 10m plus 6 equals the opposite of 8m plus 10. I'm distributing the negative, taking the opposite of the whole thing. This would be 10n plus 6 equals, negative 8n minus 10. Alright, then I would add 8n to give me 18n on the left. I would subtract 6 to give me negative 16 on the right. And I would divide by 18 to give me n equals negative 16 eighteenths, but 16 eighteenths reduces to 8 ninths. Alright, now these are not guaranteed to be solutions. That's why I'm saying in the last part here, check. Alright, so you go back to the original. Right. We check our solutions back in the original equation. Right, always the original. So with n equals 2, right, go back and replace n with 2. So we have the absolute value of 10 times 2 plus 6 on the left equals 8 times 2 plus 10 on the right. Now for absolute values, treat them like parentheses, in most cases. You simplify what's inside first. This is the absolute value of 20 plus 6. That's the absolute value of 26 equals, and then over here, this is 16 plus 10, that's 26. And remember, the absolute value is always not non-negative, right? The absolute value of a positive number will be positive. The absolute value of a negative number becomes positive. So this is just positive 26. Right? And then we have 26 equals 26. That is true. So n equals 2. All right, this is a solution of the equation. All right, now I'm going to check the other possible solution I got. Or how about n equals negative 8 ninths? All right, negative 8 ninths. Well, let's see. Left side, you have the absolute value of 10 times negative 8 ninths plus 6 equals, and then the other side, 8 times negative 8 ninths plus 10, and we'll see if this is a true statement. Now I'm going to kind of skip ahead here. All right, this would be negative 80 ninths plus, and then 6 is 54 ninths, right, when you get a common denominator. Negative 80 ninths plus 54 ninths would be negative 26 ninths. So I have the absolute value of negative 26 ninths would be, this left side would be positive 26 ninths. The right side, I have negative 64 ninths plus, and then 10 would be 90 ninths, 90 over 9. Negative 64 plus 90 would also be 26. You'd have positive 26 ninths on the right side too. And you get 26 ninths equals 26 ninths. This also works. So this equation has two solutions, 2 and negative 8 ninths. So I'm going to enter both of those. Right? Going back to read the instructions. Right? It says use a comma to separate multiple solutions. Right? Use a comma to separate multiple solutions. So they're saying here n equals, one of them was 2, comma, and the other solution was -8/9, -8/9. And I checked them and both of them worked, right? And then I hit submit, and it says, hey, perfect, great, you did it. Now sometimes you'll check a solution and it won't work, and those are called extraneous solutions, right? We may come across examples like that, just be aware of that, right? And if both solutions you find don't work back in the original equation, then the equation has no solution. You would enter this, empty set symbol as your answer, but maybe we'll get to problems like that. And of course, after you finish a problem, they'll provide you with an answer explanation, whether you're correct or incorrect. Still read through it, right? Please read through it. Just even if you're right, just to make sure you're doing everything right, and especially if you're wrong, right? And see if you can figure out where you went wrong, so that way, next time around you might do a little better. All right, next example, next question. So look, see, I'm a quarter of the way through the objective now. Most objectives probably have 4 questions. Now, of course, if you get things wrong, it'll back you up a bit, and then you'll have to complete more questions. Just try not to guess on things. It's a very similar problem here. So let's, again, I'm going to write this out, and we'll go through it. Okay, so once again, it's already set up the way I want. All right, I'll write that once more. We want the absolute value of something all by itself on one side, and then some other expression on the other. And then once I've got that, we write the equivalent. This is equivalent to saying that, u equals a, or u equals the opposite of a, and then I solve these and check. Right. So same deal here. Right? The absolute value of -7d minus 8, this expression is all by itself. The absolute value is alone, equals some other expression over here, 9d plus 3. So the -7d minus 8, that's like the u, and the 9d plus 3 is the a. So this is equivalent to saying that -7d minus 8 is equal to 9d plus 3, or -7d minus 8 is equal to the opposite of this whole thing, 9d plus 3. Right? So again, I'll be distributing a -1 over here. All right, and then we solve each of these equations, get 2 possible solutions, and check them back in the original equation. Always, always, always check your solutions. So here I would, I'd subtract 9d, giving me -16d on one side, equals, and then I would add 8 to give me 11 on the other side. Then dividing by -16, I'd have d equals -11/16. Right. Or, then here, after distributing the -1, we'd have -7d minus 8 equals -9d minus 3. That's the opposite of 9d plus 3. I would then add 9d, giving me 2d on the left, add 8 to give me 5 on the right, then divide by 2. So d is 5/2 for that equation. But now we must check our solutions. So first, let's do d equals -11/16. So the left side would be -7 times -11/16 minus 8, and then the absolute value of all that, equals, and then the right side, 9 times -11/16 plus 3. Now again, I'm going to kind of do things out loud here. This would be 77/16, right? Positive, because it's negative times negative. 77/16, and then 8, when you write it as a fraction with a denominator of 16, would be 128/16. 77 minus 128 would be 51, -51. Yeah, 77 plus 51 would be 128. Yeah, so 77 minus 128 be negative 51/16, and then the absolute value of negative 51/16 would be positive 51/16, right? So I end up with 51/16 on the left, and over here negative 99/16 plus, and then 3 would be 48/16. Negative 99/16 plus 48/16, that'd be negative 51/16. This is false. All right, this is a false statement. Remember, absolute value is always positive or non-negative, right? So you can't have something positive be equal to something negative. So that means that negative 11/16, that's a bad solution. That's what they call an extraneous solution. You may see this word, but all it means is not needed. All right. So I'm crossing it out, not using it. Negative 11/16 is no good. Now we check the other value, positive 5/2. So the left side, you have the absolute value of negative 7 times 5/2 minus 8. And again, you do this first and then take the absolute value. Equals, and then 9. Again, going back to the original equation. 9 times 5/2 plus 3. Again, I'm just going to say things out loud. Bear with me. This would be negative 35/2 minus 16/2. 35 and 16. This is negative 51/2, but the absolute value would be positive 51/2, right? So I have positive 51/2 on the left side. And then 45/2 plus 6/2, that'd be positive 51/2 on the right side. And this is true. All right, so this is okay. This is good. So one solution that I found doesn't work back in the original equation, right? They called it extraneous. The other solution was good though. 5/2 is totally fine, and that seems to be the only one. But always, always, always check back in the original equation. So what I'm entering here is just simply 5/2, right? The only one of those that worked. 5/2. And submit. Wonderful. Again, go through the answer explanations. See, they do the same thing. See, negative 11/16 does not check, doesn't work, as we showed earlier. All right, moving on. Next question. Same objective. It's just the one objective the whole time, and they're all pretty similar problems. This is actually, again, all three of these so far have been very, very similar. The same setup. So I'm going to write this out on a separate sheet of paper and work it out with you. Same deal, right? Same as the previous couple examples, previous couple of questions, right? It's already set up this way, where I have the absolute value of something on one side, all by itself, equals, and then everything else on the other side. Absolute value of u equals a. And then I take this, once this is written this way, the absolute value alone, and write it as this equivalent expression, or the equivalent statement. The only way this is happening is if u is a, or if u is the opposite of a. All right. So I'll be doing that here. All right. This is already set up the way I want. The absolute value of something by itself, right, the absolute values alone, equals some other expression. So either this negative 7w minus 9 is equal to 8w plus 3, or this negative 7w minus 9 is equal to the opposite, right? Negative 1 times the quantity 8w plus 3. And don't forget, you're doing the opposite of that whole thing, that whole expression. So I will be distributing a negative again over here. Alright, so this first equation, if I subtract 8w, I'd have negative 15w on the left, and then I would add 9 to get 12 on the right. Then divide by negative 15 to get negative 12/15, which would be negative 3/5. No, 4/5. Sorry, negative 4/5. All right, because 12 is 3 times 4, 15 is 3 times 5. You'd cancel the 3's. Right? So this is one value I'm going to check back in the original equation. And this one, after distributing the negative, you'd have negative 7w minus 9 equals negative 8w minus 3. Then adding 8w gives me 1w on the left. Adding 9 gives me 6 on the right. So here are the possible solutions. Right, negative 4/5 and positive 6. But then we must check back in the original equation. So first, negative 4/5. So we have the absolute value of negative 7 times negative 4/5 minus 9 on the left equals, and then 8 times negative 4/5 plus 3 on the right. So the left side, you'd have 28/5, positive 28/5 minus 45/5. All right. 28/5 minus 45/5. Right, after getting a common denominator, 28 minus 45 would be negative 17. So you have the absolute value of negative 17/5, which would be positive 17/5. So the left side would end up simplifying to 17/5. And again, I'm not writing out all the steps. I'm assuming that you have some sort of arithmetic skill. On the right side, that's negative 32/5 plus 15/5. Negative 32/5 plus 15/5, that'd be negative 17/5. So, that's false. The left side's positive, the right side's negative. You can't have a positive and a negative be equal to each other. So going back, we're saying, hey, negative 4/5, that's one of those extraneous solutions, right? That does not work. So I'm going to cross it out, get rid of it. Then we check w equals 6, right? So the absolute value of negative 7 times 6 minus 9 equals 8 times 6 plus 3. This would be negative 42 minus 9 would be negative 51. Absolute value, you have positive 51 on the left, and then 48 plus 3 is positive 51 on the right. That is true. Right? That is totally good. So the only solution that works is 6. And again, if that didn't work, then I would say there's no solution. Right? If all the solutions you found don't work, either you made a mistake, so go back and through and check your work, or the equation has no solution, which is also possible. All right, but the answer is 6, right? The only one that works out is 6. So that's all I'm going to enter when they have w equals 6 here. And submit. Great. All right, looks like I got one more question to do to complete the objective. And amazing, it's set up the exact same way. All right. So once again, I'm going to write this out and set up the two separate equations, solve them, and check the solutions. Same procedure I've been going through for all these. All right. So once again, I want this setup. All right. Want to move things around so that the absolute value expression is alone, which it already is. Right. There may be some other problems where you'll have to move things around, doing some adding or subtracting or multiplying or dividing to get the absolute value alone. So just keep that in mind. And then equals some other expression. And then this should be equivalent to the statement u is either equal to a or u is equal to the opposite of a, right? Negative 1 times a. And then you solve these equations here and check your solutions back in the original. All right, I'm doing the same thing for every single one of these. So this statement here is equivalent to saying that 5x plus 9 is either equal to 9x plus 4 or the opposite of 9x plus 4, right? 5x plus 9 equals the opposite of 9x plus 4, right? Negative 1 times the quantity, 9x plus 4, so we'll have to distribute a negative over there. All right, then I solve each one of these equations separately and then check the solutions back in the original equation. All right, so first, this equation, I'd subtract 9x to give me minus 4x on this side, subtract 9 to give me negative 5 on that side, divide by negative 4, and a negative divided by a negative is positive. That'd be positive 5/4 is one possible solution. Or, all right, after distributing the negative 9, here we have 5x plus 9 equals negative 9x minus 4. And adding 9x would give me 14x on the left. Subtracting 9 would give me negative 13 on the right. Dividing by 14 would give me negative 13 fourteenths. So one of these might work, one of them, and if both of them don't work back in the original equation, then you say no solution. Well, let's see. All right, let's check the solutions. So x equals 5/4. So the absolute value of 5 times 5/4 plus 9, is that equal to 9 times 5/4 plus 4? And again, I'm going to do the arithmetic in my head and just tell you what it is at the end. So this is 25/4 plus 36/4. 25 plus 36 would be 61. So this is the absolute value of 61/4, which would be 61/4. And then here we have 45/4 plus 16/4. 45 plus 16, when you get a common denominator. 45 plus 16 is again 61. This would be 61/4 also. This is true. Right? We have 61/4 equals 61/4. So 5/4 is a totally valid solution. That does work back in the original equation, makes the original statement true. Alright, let's try the other one, negative 13/4. Or sorry, negative 13/14. So I have the absolute value of 5 times negative 13/14 plus 9 equals 9 times negative 13/14 plus 4. And right away, I can tell you that this side on the right is going to be negative, so this is not true. All right. Let me just do that right side right now. Let me show you. 9 times negative 13/14. 9 times 13 is 117. All right, 90 plus 27. So it's negative 117/14 plus, and then 4 times 14 be 40, and 16, that's 56. 56/14, right? 56 over 14 is 4. And you see how putting these together would be negative? I really don't even care what the number is, but the right side would be negative. You have negative 117 plus 56 all over 14. This is going to be a negative number. And, the absolute value of some number can't be negative. Right? This cannot happen. This would be a false statement, no matter what you found. Right? So you could actually find the numbers themselves. I mean, it wouldn't be that hard, but I can tell you right now that that's not going to work. All right, so negative 13/14 is one of those extraneous solutions. Again, it doesn't work back in the original equation. So the only one that does is positive 5/4, and that's the only one I'm going to enter. So x equals 5/4. Submit. Wonderful. And again, read through the answer explanations. You see they come up with the 5/4, they come up with the negative 13/14, and say, hey, when you check them, only 5/4 works. Right, just like we did. Right, and that should have completed it. Hooray. Right, and that's the only objective, right? So you should be seeing after completing the objective that the assignment is complete. You won't see the word preview. And I'm hoping that watching me go through these several examples help you out when you're working on this assignment as well. Just remember that you may see different questions than I saw, but it's still the same objective. You're still performing the same procedure, and finding the solutions in the same way. All right. So again, hope this helps when you're working on section 2.7 part 1 on your own. And thank you for watching.